Hey guys, welcome to the second video of operating system. So in this video we're going to discuss about the system calls and the kernel mode. How the kernel mode works and what's that word system call. So in this video we are going to discuss about this stuff. So let's begin. In this presentation, we have the things about the operating system, how the user programs work, and examining the user mode and the kernel mode, which affect the system security, how this is important for the system security. So let's begin. So here we have the first slide in which we can be discuss about the what is system call. So system call is a kind of thing which provide you the interface to communicate with the kernel. So what that kernel is? So think of as a secure system which have the as for now you can be think of it as a secure system which can have a greater independence. We can cover it later. So the system calls are as essential between the user level process and operating system. So system call by the system call we have the some interface with which we can able to communicate with our operating system kernel. Yeah, on the second one we have the request OS services. So it's provide us the different programs to interact with the operating system. Either you can be using word or you can be using any taskbar to manipulate anything. That's all the stuff is provided by the system to interact with the or make a request on the operating system to do something. So here we have the third one is secure access. The system call is preferred way to do that, because when things are in the system call, then the accessing the hardware and the perform the privileges in the systematic manner. This can be happen one by one, and the request gone to the our kernel or the operating system in the serialized manner. This can be preventing from any effect on our operation or privileges. So now I move on the other. We have the category of the system process calls. So here we have the categories, three category of process control. First one is life cycle. So how the life cycle works? Life cycle as the sequence mentioned, forking the project means just creating a new process, and the second one is for executing that project, and the third one when the process is complete then exited. Whenever some of the process is be in the stack or in the case of wait, it's waiting for some again allocation of the memory, so that's why it's put in the wait mode. Yeah, when the process is completed then it's came across the termination mode. So the second one we have the process attribute. What mean by the process attribute? So it's a kind of function which help us to create process IDs. Here we setting the user IDs, process IDs, and with this we are able to control the process attributes. Yeah, the process attribute, with this we can be able to control the different aspects and identifying the different entities in our operating system. Let's take a practical example of it. If we are in the cell or in the bash, git bash, then we are creating this. These things are the kind of terminal only. So if we are in the terminal, we are creating a process, not actually we, but our system is creating the process, then executing them. New program is launched. Okay. So in the case of Windows, create process function will be executed and our program got executed. So let's move on the next. So here we have the file management, how the file management work in system calls. So as you see, this is the different categories of the system call. The first one is process control. The second one is file management. So what's happened inside the file management? So first one is the really important thing that every file management system have file operations. So these are the open, read, as their name define their function itself. Open file, read file, and then write in it, close the file, unlink the file. Unlink file means deleting that file. So it's really important whenever your work was finished, then you need to close your file. It's really important to prevent from memory leak. So we are discussing about the attribute management. So what that the attributes management? CM mode and stats is for the file permission and metadata. It's managing the what level of access the file have. Either it have the kernel mode access or the user level have access. What the access it have. So the third one is, let's take an example and think and brute force our mind to set up this. So here's the text editor utilized for the system calls interaction. We are using the text editor to interact with the our operating system. As usual that I give you example before about the text editor that interact with the internal operating system with the method create function files. So let's move on the next slide. Here we have the third category, device management. So with system calls, we also able to so with this we also able to do the device management. So basically how this work. So the system calls happen. Let's read once, then I have explained you. Requesting device. So system call facilitating requesting and releasing the accessories as well. Whenever that's take the example as we have before, the word. So word that we utilize for the interaction. So word needs some RAM, or for some kind of processing it also needs some time for CPU for the some time. So that's how they wanted the access of the various hardware devices and then release them. So this request is managing using the call stack. Device interaction. They enable direct read from the writing in the device driver for operation. In the case of some of the extra things in which we need to talk or communicate with the driver, so at that place it's really helpful. So take an example of it. The program uses this call stack interact with the printer. So that's how you can be print something. So you need the printer to that driver. If you want to play any game, so you need the graphic card for this. That's how the device management works. So we have some other key categories that involve information maintenance that can be happen internally. We doesn't need to be too much about that. We are able to do that, but we doesn't need to interfere in that. So here with the get time of day, you can be getting the time and sys input. With this we are able to get the information from it. So the last two are remain the communication. What that communication means? Communication means that the network operation include circuit creation, data transfer. With the communication between the different processes, we are doing that communication using send and receive for the data transmission, or socket IO is a kind of library which we can be used, or it's a socket function itself. We can using this for the internal communication or real-time communication, especially used for the real-time communication. And the next one is the memory management. How the memory management work? Its functionality can be managed by the OS itself by mmap center and PRK. This for the memory management. Yeah, we have come across the modes of access in our system. Here we have the two modes of access: user mode, kernel mode. User mode means limited resources access. Most applications run in this mode. As you see, the user have the limited access as respect to kernel. Kernel is a hardware and system resources. It have all the accesses and able to execute everything in the system. It's have some disadvantage which whenever we have the kernel access, we need to be take the decision precisely to resist from the internal damage. No, the last one is how we transition from the system. So system calls and the hardware interpreters help us to make a smooth transition between them, moving from the user mode and kernel mode and then back to the user mode. So there's the privileges level and protections we have. So CPU offer as you see, we have the zero privilege separations, zero ring for the kernel for all the access, and the three ring for the users for limited access. The memory protection, the mechanism prevent user processes to kernel mode area. So how does memory protection happen? As you the kernel mode or the user. So with this we can able to resist or save our system. Kernel mode help us to secure the processes and the data. Okay, so we are so third one is input output protection. Direct hardware access from the user mode is restricted from the security reasons. So with this we are able to not able to interact with the software hardwares because we are doing the operations, but the things depend on the kernel only. Is that the beneficial for our system or need some improvement? So that's why things are in the hand of kernel only, and the normal user mode are somehow restrict from this processes. Seg faults. So as that unauthorized memory access trigger segmentation fault protecting system integrity. So this is something that can be related to the privileges and protection. Whenever some tampering happens, then it can be triggered some fault or disrupt the system integrity. That's why we are maintaining some kind of kernel mode for that. We it's also do the two-factor verification. As you see, it's appear a kind of pop-up that say is that you want to do it's regularly frequently appear on your screen if you are doing something that kind of thing that tampering the privileges system privileges. And now move on the next slide. Here we have the why separation in critical for security, why the separation needed. So here's the some factor: system stability, preventing miscellaneous fact and the faulty program to be crashing and testing. So for the system stability, we obviously need that for resisting our system from the miscellaneous activities and faults. Data protection, need to secure our data and our resources, prevent from unauthorized uses of it or someone outside of it are able to access our data. So it's completely restricted. The third one is resource sharing. So resource share is something this sharing. So it is maintaining the secure place from where we are able to take the use of the resources whenever we need it. This can be done using the process scheduling. When some process needs some resource, we can just locate for that time only. It's a optimal way to share the resource. Sandboxing was that the sandboxing is user application restrict environment, limited damage or vulnerability. So is that something that restrict the environment from being damaged. So it's you can think of it as a protected layer that can be prevent our system from being damaged or our environment being damaged. So as you see, restrict environments for the user application and the limited damage from the vulnerability. So it's kind of protection layer available. Okay, the next one we have at the end of our slides, and so the last is system call and security. Let me summarize what the need of the system calls is. Essential bridge. So what that doing is system calls is a vital connection between user application or as we see. These are making the connection between user application and internal activities via kernel. The second one is critical separation. User mode, various kernel mode provide essential security as we say protecting some privileges. We have different kind of privileges. User mode and the kernel mode. Kernel mode have some extra access to protect the system. Secure design, understand this architecture crucial. So we need to understand how the things functioning and how it's working to make the process and our operating system work really fine. So I hope you like the video. If you like the video, then do subscribe our channel and hit the bell icon. So if you want to, you can be also be check out our playlist. Is the second episode of our playlist, and from here you are able to find the whole playlist of operating system. So don't forget to subscribe, and if you like the video, then please share with your friends, families, and the people that really need that. Thank you.